Welcome to The Explainer, where we break down the big topics behind the headlines. Today, we're diving deep inside our planet to look at this invisible shield that protects all of us. And you know what? It's doing something really, really remarkable. So let me ask you, where on Earth is the North Pole? Now, you probably think you know the answer, right? But the thing is, it's not staying put. Not anymore. For centuries, the magnetic North Pole was pretty predictable. But recently, it's like it packed its bags and started moving at a wild speed. So what's happening is pretty dramatic. The magnetic North Pole, after chilling out in the Canadian Arctic for centuries, is on this high-speed road trip away from its old home. Sometime after 1990, it's like it just floored it. It's already crossed into the Eastern Hemisphere, and get this, it's now making a beeline for Siberia. And when I say high speed, I'm not kidding. At its peak, this thing was moving at 60 kilometers a year. To give you some perspective, that's 4 times faster than it was moving for most of the 20th century. This sudden sprint has scientists who track this stuff, well, pretty baffled.
And you don't have to take my word for it. Listen to Dr. Siren Began from the British Geological Survey. He says, quote, "This is behavior we've not observed ever before." And he points out that it makes trying to predict what the magnetic field will do next a whole lot harder. This isn't just some slow drift. It's a real change in the system.
Okay, so let's get into the science of this. What exactly is this invisible shield? And how in the world do we keep tabs on something that's constantly on the move? All right, picture this. Almost 3,000 kilometers right under our feet, there's a massive ocean of churning liquid iron. That's Earth's outer core. And all that movement, what scientists call the geodynamo, generates this incredible, invisible force field that wraps around our entire planet. It's our shield protecting us from a ton of nasty solar radiation. Now, here's the kicker. Because that liquid core is always churning, the magnetic field is always changing. It's chaotic. So we need a super precise map to keep track of it all. And that map is called the World Magnetic Model, or WMM for short. They have to update it every 5 years just to keep our navigation systems from going haywire. And creating this model, whoa, it is not a small job. It's this huge international effort headed up by organizations like the US National Geospatial-Intelligence Agency and the British Geological Survey. They're pulling in data from satellites way up in orbit and combining it with measurements from all over the ground to build the best possible picture of our planet's invisible shield. And you might be asking, who uses this? Well, the list is pretty staggering. We're talking about major global defense groups like NATO and the US Department of Defense. Every single international flight and cargo ship relies on it. The energy industry needs it, and yep, even that little compass app on your smartphone. They all need the WMM to be accurate. So we've got this wandering pole, right? But that's just one piece of the puzzle. It turns out the pole's journey is just a symptom of a much bigger story. There are other really strange things happening with our magnetic shield, and they're all probably connected to that same chaotic dance happening deep in the Earth's core. One of the biggest things scientists are watching is this giant dent in our magnetic shield. It's called the South Atlantic Anomaly. Basically, it's this huge area over South America and the Atlantic where the field is way, way weaker than it should be. This lets dangerous solar radiation get a lot closer to the surface. And this weak spot, it's not just sitting there. Oh no, it's on the move. It's expanding westward at about 20 kilometers a year. And the latest data shows it's actually starting to split into 2 separate weak zones. This is a real headache for satellites because flying through this region can mess with their electronics. So you've got this weakening shield, and at the same time, the sun is waking up. It's entering a more active phase of its natural 11-year cycle. A more active sun plus a weaker shield? Yeah. That means we're more vulnerable to what's called space weather. And we've already seen what this can do. Remember that massive G5 solar storm back in May of 2024? During that, compasses in some areas near the poles were off by more than 15 degrees. Then another storm in October pushed that to almost 17 degrees. For a little while there, magnetic navigation was basically useless. These are the kinds of immediate dramatic impacts we're talking about.
Okay, so solar storms are one thing, but what does a constantly wandering pole and a dented shield mean for us, day to day? Well, the impacts are probably a lot more direct than you think.
The change is so fast and so significant that it's forcing these urgent updates across all sorts of critical systems around the world.
Basically, when the magnetic field moves, everything that relies on it has to be recalibrated. It's a constant chase.
Just think about the scale of this for a second. Airports are literally having to repaint the numbers on their runways because those numbers are based on magnetic headings. The military needs this for things like submarine navigation, to stay hidden. Energy companies depend on it to drill for oil and gas with pinpoint accuracy miles underground. And yeah, your phone's map and compass apps need the latest model just to point you in the right direction.
So here's the simple breakdown of how this affects your compass. There's true north, the very top of the globe, a fixed point. And then there's magnetic north, the spot your compass needle actually points to. The angle between those two is called declination, and because the magnetic pole is wandering all over the place, that angle is changing for everyone, everywhere. Without the WMM constantly updating our devices, our navigation tools would slowly but surely lead us astray. Okay, with all this crazy stuff happening, the pole sprinting, this big anomaly growing, it all leads to the big one, the ultimate question: are the poles getting ready to completely flip?
Well, the good news is, while these reversals definitely happen, the geological record shows they are incredibly slow processes. We're talking thousands of years. The last full flip was about 780,000 years ago. We have seen shorter, temporary flips, but right now, most scientists agree that there are no signs a full-on reversal is about to happen anytime soon.
But, and this is a big but, even those temporary events can be really dramatic. Take the Lost Champs event, about 41,000 years ago. During that little excursion, our planet's magnetic shield got super weak, down to just 5% of its strength today. That would have left the surface much more exposed to the harsh environment of space.
And there's a beautiful side to all this. If you've ever been lucky enough to see the northern or southern lights, the aurora, you can thank our magnetic field. It acts like a cosmic traffic cop, grabbing those dangerous charged particles from the sun and funneling them safely down towards the poles. When they hit our atmosphere, bam, you get that incredible light show. So as our shield continues to change and potentially weaken in spots, we could see the effects of solar storms become more intense. But the flip side is, we might also get more spectacular and widespread auroras, visible from places that almost never get to see them today. It's a powerful, dynamic system, and we're living through a really remarkable period of change.
I think the main thing to take away from all of this is that our planet isn't just some static rock floating in space. It's a living, breathing, dynamic system. And this wandering shield of ours is just a powerful reminder of the incredible, chaotic forces that are constantly at work deep down beneath our feet, shaping our world every single day.